understand why it has gone there? Okay, so I understand why it has gone there. For some reason, it has gone there. So now what I'm going to do is I'm going to bring in one more magnet. Oh, they are attracting. That means what I've done is I've made a mistake. So I need to, okay, let me see if this also attracts. This is not attracting. That's okay. They all should be rippling. So now what happens is that, see, I did not separate them, but they themselves got separated. Okay, see here? I'm just trying to push it closer to it. It's not going closer, but it is they both are getting, they both are pushing each other. So can you tell me like why it is like coming back like this? Can anybody tell me?
Because of this, they are rippling each other, and the cap is lightweight, so it's ripped and it's flowed on the other side of the magnet.
Okay, so basically the magnets are rippling first thing. The cap is lightweight, that's okay. And the most important thing is there's something called as friction, children. Can you tell me what friction is? What is friction? Okay, friction is something which stops the motion, right? Friction is something which stops the motion. Okay, but in this case, what is happening? Because it's in the water gives the least friction. Okay, so see this also I bring it like it, they just go away, and what they do is they exactly stay apart to such a distance where they are able to equally balance themselves. Okay, so now I'm going to put the third one, see what's going to happen. Oh, but why is it attracting? Just now I changed the phase of it. Okay. Now what did it form? What is the shape that yeah, what is the shape that forms? Yeah, when there are 3 points. Okay, it's triangle. Okay. If there are just 2 points, what is that?
It is known as a line segment or line.
Exactly. If you get only 1 point, what is that you can draw?
Line.
Sorry?
It is a point.
It's a point with 1 point. What is that you can draw?
We can draw anything with a point.
No. There's one shape which you can draw.
Lines.
Sorry?
Circle.
Circle, exactly.
Circle.
Right. Yes. Siddhant, you're right. Okay, so with 1 point in the center, the shape which I can draw is a circle. Okay, see now, whenever we want to fix something, what happens is that, okay, so suppose I like take this thing and fix it only at 1 point, then what happens? This will be free to move. That is, it will be free to move all round if it is just 1 point. So it is a circle that we have. So if I don't want this to move and I want this to stay at 1 point itself, exactly like this, what I have to do is I have to fix it here and I also fix it on the other side. So we need 2 points for a line. For a line, we need 2 points. Okay. See how automatically they get arranged. Okay. So now 2 points is line and 3 points is a triangle. Okay. So then what happens if I introduce one more magnet? What would happen? What might happen if I introduce one more magnet here?
It will be square or rectangle.
Sorry, Siddhant, can you repeat?
It could when we added one more magnet with a cap, it will be a square or rectangle.
Okay. Yes, it might become a square. Okay. So later on, like suppose I add one more magnet, what might happen? One more magnet. What might happen with one more magnet? So one magnet, adding one magnet, it's like it becomes square. Suppose I add 5 magnets. What would happen? Exactly. So it becomes a pentagon. So with this, yeah. So with this simple arrangement, yeah, with this simple arrangement, children, like we'll be able to do several steps. Okay. So we can make what mathematical shapes out of this. Another important thing we can learn is the friction. Okay, because in water there's no friction. So as soon as you put something like add one more magnet, they all automatically get adjusted. Okay, so this is the same way how our ecology is. What do you mean by ecology? What do you mean by ecology? Can anybody tell me what ecology is? Can somebody tell me what ecology is? Okay, in the nature, what happens is everything has been fixed at a particular place. Okay, suppose we'll just think this thing, what we have made, this triangle. So to form this triangle, everything is important. Okay, so in the nature, everything, plants, animals, human beings, like all are important. Okay, and trees, like whatever, all the even the smallest microbes, even they are important in the nature. Okay, so ecology, what do we mean by ecology is that, okay, the great balance between all these species. So we call it as an ecological setup. Okay, suppose I just remove one out of this, what happens? The ecology gets disturbed. Okay, now it's no more a triangle. Okay, right now it has become a line. So it's very important that like we don't disturb the ecology. So we give space, equal space for like all the species, so that the ecology is continuous, completely maintained. Okay, so that's other important concept. Actually, I could derive out of this activity, that whenever I disturb, even if I add something, even that disturbs, that changes. Okay, so even if I add something, one more magnet here, what happens? The existing system will change. So it's very important that we don't disturb the existing system and like we just maintain it. Okay. So, but it's a very fun game. Like you can create like a lot of shapes out of this. Okay, and also like you can see how if there is no friction, even the lightest of power, actually this magnet is not like very powerful. Okay, this magnet is not really powerful, but still, if on the water, on the water, because there is no friction, even if it is right now, I just put a small bowl kind of setup. Okay, but even if it is a big tub, you can feel that the magnetic force acts on the magnet that is there on the other side of the tub. Okay, even if it is a big tub. So that also tells us how far, even if it is a small magnet, not powerful, we might feel that it's not powerful. We can see that the magnetic field can go spread across the tub and influence the magnets on the other side. Here I'm just moving one magnet and you can see that like everything else moves, because can you tell me what is there around the magnet? We have been discussing this for several classes now. What is there around the magnet? Can anybody tell me?
Microorganisms.
No. Around the magnet is a special component, which I have said that for all other components, the strength of the component would lie inside it, center of the object would lie inside the object. But for magnet, the strength is around the magnet. Okay, so but that is invisible to us. We can just feel it. So this is other very good example or very good activity to what feel that the magnetic field is like all around the magnet. See, we are just not even touching it, but still they are all three are moving, not just one. Okay, all three are moving just because all three are trying to adjust themselves to a place where the forces is like equal from all sides. So we call this as the equilibrium of forces. Okay, they all try to adjust. Here I will take closer. You see what would happen, and like, okay, they all basically they are trying to adjust such that the forces on all sides are same. Okay, they exactly stop at the place where the force. Suppose this magnet is here. Because for it is feeling that the force from this magnet and force from this magnet is like it's at the same amount. Okay, even if I bring it closer, what happens? This magnet comes on the other side because this comes here just because it saw that there is a gap here. I can spread. Okay, it saw that there is a gap here and it's basically spreading, trying to move itself. Okay, this is a very good activity. Like I would like play with this like the entire day actually. So in case you have any questions, you can ask me, children. It's a very simple activity, but it was fun. So I thought like we can do this, and I would have been happy in case you had magnets with you. Anybody having these magnets with you? So again, like I've been repeatedly telling, so these are all these simple materials for doing like simple experiments. Like, yes, Siddhant, you have these magnets, is it?
Sir, they are broken. Sir, this I have brought in 2016 or 17. It broken.
Oh, okay. No, even if it is broken, you can still do this activity. Even if it's broken, you can still do this activity. Okay. So that's what
So
like
I have a
I
doubt.
keep telling in. Oh yes, Siddhant, please you can ask the doubt. Yeah.
So we have a big tub and we are going to do several magnets on it and it float. It's ripped or
Hmm.
joined together and formed in a
No, it should.
circular shape.
No. Basically, to play with this activity, all the magnets should ripple with each other. Okay. So if it is attracting, what will happen? They all will just come and join in one place. Okay. If it is rippling, then you have the greatest fun. You can try attracting as well. Suppose you have a very big tub, you can keep one magnet on one end and the other magnet on the other end. See if they come close and just attract. Okay.
Okay.
So if it is rippling, what you can do is you can keep both magnets together as close as possible. Keep them together and release. You see that the magnet will just float and just go out, go and like hit the borders of the tub. Okay, you can try this. See, I'll be happy in case you try these activities and at least send us some short video, short photos. So we'll be very happy, and that short video and photo we can also collect and like sort of like publish it for the other people to learn. Okay. So, children, another thing I wanted to tell is that is there some other experiments which you have seen and you want that like we can try that experiment, or you tried it did not work and you want me to try, so we can also do that. See, this group which you have, it's not only like there's one ma'am in this group called Neha ma'am. So you can basically like send your videos or like photos onto that. You guys doing experiment. It can be any experiment. It need not be the experiment which we do it in the class. Any experiment you guys do it, like you can do that, so that like during the class we'll also like show all the other children who are joining of what experiments you guys have done. Okay. So maybe some photos or short videos we can play it in before the class starts. Okay. So that's one more thing we can do. Again, the idea is that I want to form a small online science club, because we all are in different places. So the online science club is easy that like we can sit at home and like we all can like perform activities together. Okay. So any questions, Satyajit? So, Ojas is there. Ojas, how are you doing?
Good. I'm good, sir.
Okay, Ojas. So yeah. So just like even you can start doing some small experiments. Again, as I said, it need not be experiments which we have been doing it in the class. Any experiment you do, you can basically send it to like Neha ma'am, and like during the class we can basically show it to others of like what experiments you have done. Okay. Yeah. What is that, Siddhant? What are you trying to do?
So it is my workshop.
Oh, show me.
It is.
You show me. I'm like, I'll be excited to see your workshop. Oh, okay. So this has all your tools. Okay, very good. Very good. Okay, great. So I'd be very happy to see some of your science experiments, Siddhant, for all of you as well. Satyajit,
Okay, sir.
Satyajit, are you joining for the first time or you have joined before as well?
I'm joining sir from first sir.
Oh, is it okay?
In middle,
Okay.
I can't be joined.
Okay, yeah. Okay, children, like, see, now it's also like the responsibility of all of us that, like, right now we are just like 5, 6, and like we want to build this team to at least about like 10, 15 children. Okay, then we can start like doing some like simple activities or during the weekend and form an online science club. So I would be very happy to do that. So you can also bring in your friends for this. But for bringing in your friends, the important thing is you have to start doing experiments. Only if you start doing experiments, you'll be able to like sort of inspire your friends. That's very important that like we inspire others. Satyajit, I think you need to mute yourself.
So I am making the bike. I think I can make the suspension of a bike.
Suspension of bike. Okay,
Yes.
so how do you plan to do it?
So we have to do a spring of
Okay.
any material springs. Then we have to have a small rod attached
Okay.
to the spring, and the
Mhm.
big hole of an iron rod can under over the small rod. So when we push on it, it's come together and exerts its power together.
Okay, yeah. Do it, like, do it, and also you can, like, once you do any experiments, na. So here you'll also be able to sort of like demonstrate it to other children who are a part of this club. Okay. Okay, good. So I'd be very happy to connect with you guys. And what I'll do is there are some very interesting videos which I want you all to see. Okay, so I'll also try to post those videos on the groups. Okay, group. So you guys can also watch those videos. Okay, fine, children. So any questions, please ask. In case you have questions, you can ask me. But this is a I wanted to do a very simpler activity so that it's easy for you to replicate, because in between we also did some little complicated activities, but I thought I did not know like whether you will be able to replicate those activities. So now we are making the activities simpler and simpler so that it's easy for you to find the material and like also like do those experiments. They are simple experiments, but there's a lot to learn out of them. Okay, fine, children. So see you in the next class. Okay, next class I would be happy to see some of your experiments. Okay, please, I'll be waiting for that. Okay.